Hello and welcome to section G.2. Here we're going to be looking at fractional exponents. So what we mean by that is if you have something like to the power 1/2, what does that mean? Or 5 to the power 2/3, what does that mean? You can't multiply 5 by itself 2/3 of a time. It doesn't really make sense. So we're going to figure out what that means and get more practice using these important exponent laws in the section uh, and dealing with kind of some messier kinds of expressions. First, you've got this warm-up to do, getting some practice with square roots and nth roots, like cube roots and fourth roots. So let's do that now if you haven't yet. All right, now that you've paused it and tried these and you're back to check your answers, here they are. The square root of 64 is 8 because 8 squared is 64. Okay, so the cube root of -8 means we want to take something and raise it to the power 3 and get -8. So what is that going to be? Well, -2 to the power of 3 is -8. So the answer here is -2. Here, let's see. I want to do, if we want a fourth root, whatever this is, it's going to be something that you can raise to the power 4 and get x to the fourth over 16. So what should go in here? Well, it's probably going to be a fraction. And whatever you have in the top, you're going to do that to the power 4. And whatever you do in the bottom, you're going to do that to the power 4 to get x to the fourth and 16, respectively. So using basically this rule here. So what do you want to do to the power 4 to get x to the power 4? How about x to the power 4 is x to the power 4. So that's the top of this. And what would the bottom be so that when you do that to the power 4, you get 16? That would be 2 to the power 4 is 16. So this is just x divided by 2. Okay, now what would you cube to get x to the power 6? Whatever this is, it's going to be a thing that you can raise to the power 3 to get x to the 6th. Let's see. Well, it's going to be x to some kind of power, probably. But we don't know what that power is. Which one of these rules tells you how you would combine that unknown power and 3? If you have a power to a power like that, it looks like this rule here. So that says you would multiply them. So we'd be doing x to the question mark, that unknown power, multiplied by 3 to get x to the 6th. So in other words, what do you multiply by 3 to get 6? That would be 2. Because if the question mark is 2, then you'll do 2 times 3 to get 6. All right, so that's a review of square roots and cube roots and fourth roots. So here's a reminder of these important exponent laws again. We're going to be using these a lot here. And if you haven't done some of the G.1 homework and you have time right now, I recommend getting a little bit of practice with that because those skills are going to help you out a lot here to be able to do these exercises and get the most out of it. So what we're going to do now is investigate what an expression like x to the power 1/3 means. Whatever it is, it would be nice if all of these exponent laws worked on it. So let's suppose they do work, and then let's try to use them here. So for example, with exercise 2, let's apply whatever exponent law works with this to simplify this. So you have x to the power 4, and then that to the power 1/2. By the way, this is an exercise, so you should be trying this on your own. So if you haven't done it yet, now's the time to pause it. But now that you've tried them, I'm going to show you the answers. So let's see, x to the 4 times, or so 4, x, I can't talk. X to the power 4 to the power 1/2. The rule that applies here is this third one. So we're going to multiply these and do x to the power 4 times 1/2. And 4 times 1/2 is 2. So that gives you x to the power 2. Okay. How about this one? If you have 5 to a power times 5 to a power, the base of these, the 5 is the same in each one, but you have different exponents. That looks like this first rule. So this is going to become 5 to the power 2/3 plus 1/3. 2/3 plus 1/3 is 3/3. And 3/3 is 1. So this just gives you 5 to the power 1, which is just 5. Okay. So for part C, this is a tricky one. If you didn't get this one right, that's okay. Let's look at a squared b to the power 1/3 first. So that looks like two things being multiplied all to one power, so you could use this rule here. And so I'm going to write this as a squared to the power 1/3, and then b to the power 1/3. And here we're going to do the same thing. We're going to do this times a to the power 1/3 and b squared to the power 1/3. So it's sort of like the distributive rule, but we're distributing in an exponent into multiplication instead of distributing in multiplication into an addition. So using that rule here. So let's see, you have a power to a power, a squared to the power 1/3. That is an example of the third rule. Multiply the powers to give you a to the power 2 times 1/3. 2 times 1/3 is just 2/3. B to the 1/3 is just that. A to the 1/3 is a to the 1/3. And b to the 2 to the power 1/3, again, a power to a power. We just multiply those to get b to the power 2 times 1/3, which is 2/3. All right, now I'm going to reorder this and do the a to the power 2/3 times a to the 1/3. And those are the same base of a. So in these cases, you can add these exponents to give you a to the power 2/3 plus 1/3. And here you can do the same thing with the b's. B to the 1/3 times b to the 2/3. Add the 1/3 plus 2/3, and you get b to that power, which is going to be 1. So 2/3 plus 1/3 is 1. So this is going to give you a to the 1, and also same thing with the b to the 1. So it's just a times b. Pretty cool. So getting this practice using the exponent laws and thinking about square roots and third roots and fourth roots is going to help us understand what this stuff is supposed to really mean. And that's what we're going to go over in the next video. Talk to you then.